Welcome back to another session in the TAE certification series. In last session, we covered first three steps that can be taken to verify the components of the automated test environment. Let's continue with the remaining steps in today's session. Let's start with number 4, configuration of the test environment and components. So this refers to setting up the space where testing occurs and assembling all the components which are required for testing. It is just like creating the ideal workspace for conducting tests. The first point is understanding and documenting the various TAS components. It involves knowing and taking note of all the different parts that make up the TAS. This includes documenting each component, understanding how they work individually, and also how they interact with each other as a complete system. The next one is necessary knowledge for TAS impacts due to SUT changes. This part stresses the importance of the knowledge gained from understanding and documenting TAS components. When the system under test undergoes changes, such as updates or modifications, it might affect how the TAS operates. So the first one is what aspects of TAS may be affected. So understanding TAS components helps predict which specific parts of the testing tools might be impacted by changes in the SUT. It's like anticipating which sections of a machine might need adjustments if another part of the machine changes. Then the second one is requirement for change in TAS due to SUT environment changes. So having this knowledge allows for proactive adjustments or modifications to the TAS setup when the SUT environment changes. Think of it as having a manual that guides you on what adjustments are needed to keep everything running smoothly when the system you are testing changes. Now, number 5 is connectivity against internal and external systems / interfaces. So when we set up TAS in a SUT, it's kind of like installing an application on your phone. So you need to ensure that the TAS is correctly placed and it's ready to do its job. So once a TAS is installed in a given SUT environment and prior to actual use against an SUT, a set of checks or preconditions should be administered to ensure that connectivity to internal and external systems, interfaces, etc. is available. Okay, so before we actually use this automation solution in the system, we have to perform some checks. And these checks make sure that everything in the test automation solution which it needs to work properly is available and they are ready to go. So let's talk about all these separately. So first, let's talk about connectivity to internal systems. So this is it is like a computer communicating with its own components like the hard drive or memory. So similarly, the automation solution should be able to talk to all the different parts of the system it is supposed to work with inside the organization. Now, the second part is external systems. So this one is like a computer connects to the internet or a printer. Just like this, the TAS might need to link up with some systems outside the immediate setup, just like, for example, let's say cloud services, databases, or even some other company's systems. So it is important to make sure that it can communicate with these external systems properly. And the third part over here is connectivity to interfaces. So think of interfaces as the way different parts of a system talk to each other. It's like making sure that all the plugs fit together correctly. And making sure that these interfaces are working means making sure the connections between different parts of the system are set up correctly for the automation solution to function smoothly. Establishing preconditions for automation is essential in ensuring that the TAS has been installed and configured correctly. Okay, so making sure that these preconditions are met is really important, because it's like double checking that the test automation solution has been set up and configured correctly. If everything is in place beforehand, the test automation solution is more likely to perform its task without any issues. So these preconditions are like the foundation of a building. They need to be solid for everything else to work well. Moving on to number 6, intrusiveness of automated test tools. When we talk about the tight coupling of test automation solution and system under test, it means that the test automation solution and the system under test, they are very closely connected or dependent on each other. So this connection is initially established to help the test automation solution in efficiently interacting with the system's graphical user interface, or GUI. But this close connection can sometimes also lead to some issues. So these negative effects may include a SUT behaves differently when the TAS resides within the SUT environment. Okay, so to understand this, let's take an example of simple login example to a website. So when people log in manually on the website, let's say it usually works fine. They enter their username and password, and if it's correct, then they get the access. Now with test automation, if a special tool tries to log in automatically many times in a short span, like let's say trying lots of usernames and passwords quickly, the website might think that it's a security threat. So it might slow down or even stop allowing logins for a while. And this happens because the tool's repeated logins make the website security system suspicious. The second one is the SUT has different behavior than when used manually. Okay, now let's again take the same example. So what happens in the manual login? When someone logs in, it is usually pretty quick and it works smoothly. Now, what happens in automated testing? If a testing tool does the login part automatically, it might sometimes be too fast or send too many login attempts in a short time. So this might confuse the website, and it can cause delays or errors that don't happen when people log in manually. And the third one is SUT performance is affected with the TAS in the environment, or when executing the TAS against the SUT. So when the website is used normally, it is usually fast and responsive. But when the testing tool is busy running lots of logins during automated testing, it puts extra work on the website. This might make the website slower than usual, or even temporarily stop it from working properly, because the tool is making the website do a lot of things at once. So in simple terms, using a testing tool to automatically log into a website can sometimes make the website act differently. It can cause variations in how it responds and even slow down its performance, because the tool is doing a lot of things quickly that the website is not used to handling all at once. Okay, moving on to the next point, the level of intrusiveness differs with the chosen automated test approach. So different automated test methods, they affect the system in different ways. So some minimally disturb it, while others can seriously disrupt its operation. So let's see the examples of all of them. So the first one is the low intrusion. So interaction via external interfaces, for example, electronic signals for physical switches, USB signals for devices, minimally impacts SUT software. So this method involves using connections like electronic signals or USB connections to talk to the software which is being tested. So it's like pressing buttons or using devices that send signals to the software without changing how the software actually works. For example, think of how a remote control interacts with a TV. It does not change how the TV works internally, it just sends commands. Okay, second one is end user simulation without altering SUT software behavior or timing. So this one is like pretending to be a regular user using the software, but without changing how the software behaves or how fast it responds. So for example, imagine clicking buttons on a website the same way a person would. So the website responds as if a person is using it without any changes inside the website itself. So now if we look to both examples in point 1 and in point 2, both of them involves interaction, but the first example focuses on using external signals to communicate with the device or software without changing its internal functioning, while the second example, it is kind of demonstrating mimicking user actions without modifying how the software behaves internally. So that's the difference. Then the third one. Sometimes using these outside connections can be tricky because it might need special tools or languages that describe how hardware works. So this way of testing is more common in products like, for example, microwaves or cars that have software connected to physical parts. But for software-only systems like applications or computer programs, this method of testing is not used as often because they do not rely on external hardwares as much. So after the low intrusion, let's move on to the moderate intrusion, which is the GUI level interaction. And the first point is SUT environment adapted to inject UI commands and extract necessary test information. Okay, let's understand this one. This means that adjusting the system so that it can understand and respond to commands related to how users interact with its interface, like clicking buttons or entering text. So it involves modifying the software being tested to collect important information which is needing for testing purposes. For example, think of modifying a website so it can detect and respond to specific test commands or gather necessary data while people interact with it for testing purposes. The second point is timing impact on SUT behavior, higher intrusion than external interfaces but less complex. So this method affects the timing or speed at which the system under test operates. So when I'm saying this method, we are talking about moderate intrusion. Okay, so it interferes more with the SUT than using external interfaces, but it is simpler than some of the other testing methods. For example, it might slightly slow down or change how the software behaves, but it is not as complicated as some other ways of testing. The next one is often uses commercial off-the-shelf tools for automation. So this approach frequently relies on ready-made tools that are available for purchase rather than creating specialized testing tools from scratch. It's like using tools that are already made and commonly sold for automating tests instead of building entirely new ones for this specific purpose. So to summarize, this testing method involves modifying the SUT environment to handle UI commands and gather test data, slightly impacting the timing or behavior of the system, and often using readily available tools for automation. Let's move on to high intrusion, which will include test interfaces / APIs. Interfaces used explicitly for testing, possibly not utilized by end users. So this means creating special pathways or connections in the systems, or we can say it APIs, mainly for testing purposes. So these APIs might not be meant for regular users, but are specifically for testers to check that how the system works. For example, imagine adding secret buttons or hidden commands in a video game that only testers can access to check the game's behavior. Potential significant impact on SUT behavior and functionality. So this method of high intrusion of testing could potentially cause a big change in how the system operates or behaves. So it might significantly change how the system functions during testing compared to its usual behavior. So for example, tweaking or using these special testing pathways, APIs, could make the system behave in unexpected ways that are not typical in normal use. Higher level of intrusion, but easier and cost effective for automated testing. So this testing approach involves more interference or influence on the system than some other methods, but it is simpler and more cost effective for automated testing. It's like having more access or impact on the system during testing, but it's easier to automate these tests without spending a lot of money on complex tools. And the last one is risks understood. Failure detection might differ from real-world use conditions. So when using these APIs, it is important to know the risks. Sometimes the way the system detects failures during testing might be different from how it happens in the real world situations. For example, if a failure occurs while using these special testing pathways like the APIs, the system might react differently than it would if the same failure happened under normal conditions used by regular users. Next, we have impact on test confidence and analysis. And the first point is high intrusion levels can reveal failures not apparent in real world conditions, leading to reduced confidence in the automation solution. When testing heavily interferes with the system, like high intrusion, it might uncover problems that do not happen in normal use. And this could make testers less sure about the reliability of their automated testing method because it finds issues that real users might never encounter. For example, let's think of a car testing scenario. So during intensive testing, a special tool is used to simulate extreme conditions on the car, which reveals a rare issue with the engine that almost never occurs during normal driving. This issue is only discovered because of the intense testing. Then the next point is developers might require reproducing automated test failures manually to aid analysis and solution identification. So taking the same example of the car, now let's say the engineer is running the test, notices that this engine problem found by the testing tool. So to understand it better, they need to manually recreate this issue by mimicking the exact conditions found during the automated test. By doing so, they can investigate and they can come up with a solution to fix the problem in the engine. And the last step, number 7, is framework component testing. Testing automated framework components. Much like any software development project, the automated framework components need to be individually tested and verified. So like making any computer program, the different parts of the tools which are used for automated testing need to be checked one by one to make sure that they work correctly. This may include functional and non-functional performance, resource utilization, usability, etc. testing. So this checking involves that making sure that these parts do their job, which comes under functional testing, and work well in various situations like how fast they work and how much computer power they use and how easy they are to use, which will come under non-functional testing. Now let's have a look at the functional testing examples. Verification of components providing object verification on GUI systems requires testing across a wide array of object classes to ensure proper functionality. So for example, checking if a testing tool can accurately identify and interact with various screen elements like buttons, drop downs, or text fields on a website to ensure that they all function properly. The next one is error logs and reports must accurately reflect the status of automation and the SUT behavior. So this one is like making sure that the records and reports created during automated testing, they show any mistakes or problems found accurately. So for example, ensuring that error messages describe problems correctly without giving any wrong information. Then we have non-functional testing examples. Examining framework performance degradation and assessing system resource utilization aids in identifying issues like memory leaks. So for example, running an automated testing tool for a long time and then noticing that it gradually uses more and more computer memory, which indicates a possible memory leak issue. Then we have evaluating interoperability of components within and / or outside the framework is part of non-functional testing. So testing if different parts of the testing tools work well together or with other software is part of non-functional testing. For example, checking if like the testing tool works smoothly with existing software systems or if it causes problems when they interact. With this, we have finished section 7.1. In our next session, we will proceed with section 7.2. Until then, take care and happy testing.